All right, we are going to start with rational functions today. 8.1 rational functions. Rational functions are somewhat easy, right? If you remember what a rational number is, it's when we have fractions now, as opposed to just an integer. Rational numbers deal with fractions, decimals, and so forth. Well, rational functions do that. They have a denominator that may have a variable. So they could be on the top and the bottom, or just the bottom for the first couple pages anyway, for these first notes. So the most simplest parent function of a rational function is 1 over x. And we're going to look at that function over the next, page and a half, and that'll be our first video here. So let's do it without graphing on a graphing calculator, and we're going to do it by plugging in numbers. So if I plug in -2 into this position of x, I get -1/2. I'm going to come over here and plot that. -2 gives me -1/2. If I plug in -1, I get -1 over 1, which is let's put it on the right spot. Let's delete that. And -1/2 and -1. If I plug in a -1/2, remember if I plug it in there, it flips over and becomes a -2, which we're going to plot right here. -1/2, -2. And a -1/4 goes to -4, and wow, that's growing quick. Let's connect that. All right. Now on the other side, if I plug in a 1/4, remember if it put it on bottom, it flips over and becomes a 4. I'll put a dot there. If I plug in a 1/2, that's 5/10 or 1/2, I get out a 2. So 1/2 will get me something here. When I plug in 1, all right, 1 over 1. And then it starts, you can imagine what happens. I plug in 1/4, 1/5. It starts to really approach, and as I plug in like 100th, 1,000th, they flip over and become this really shoots up fast as you approach 0. And there's our basic graph right there. We're going to note that there's some reference points that we may play around with. This 1, 1 is a nice quick reference point. This -1, -1, they're listed here. And they're reference points when we start to transform things. We'll talk about that in the next video. So let's do the end behaviors. All right, so the end behavior is this. Let's say it. Let's say as x approaches infinity, what does y do? It looks like it's approaching the number 0. So we're going to say y approaches 0, and as x approaches -infinity, well, y seems to approach 0 as well. So we're going to state the range of this. How far up and down? Well, it looks like my range is, it goes down forever to -infinity, and it comes up and almost touches 0. Doesn't quite touch that. Union, and it picks up on the other side, right? Y starts off almost touching 0, and then it shoots all the way up to positive infinity. So kind of some behaviors of this graph. Now we're just going to examine what happens to this graph as it gets close to x is 0, as it gets close to this part, right, where x is 0, this y-axis. So as I plug in 100th, that's what that is. Remember, it would flip over and become 100. 1,000 would flip over and become 1,000. 1/10,000. So this thing is shooting up fast. I mean, over the space of maybe 1/10 to 1,000, I've shot up, oh my goodness, almost actually 9,000ths right there. On the other side, I got -100, -1,000, -10,000. And this kind of explains this drop off. Like when I plug in 100th, I'm shooting up to 100. So we can see this rapid increase on this side and rapid decrease on this side. So we're going to assess this. This is rational functions create an asymptote. An asymptote, which is, I'll draw the line in. This is called a horizontal asymptote because it goes horizontal. This is called a vertical asymptote, right? And it says, what asymptotes do you see on the graph? How do these relate to domain and range? Well, the asymptote that I see is I see x equals 0, and I see y equals 0. All right? So that's kind of amazing. We get some points on the graph, 2 lines that are never ever touched. All right? And how do you relate to the domain and range? Well, these kind of create our domain and range, right? So this y equals 0 kind of interrupts our domain. If you look here, y equals 0 stops our domain from going over all real numbers, right? And x equals 0, which is this horizontal line, messes with our range, right? It goes from here to here and here to here. So let's talk about that on the top of the next page. All right. Now, we got page 2 here. In fact, I take it back. Let's go ahead and write it here. All right. So we will be talking it. So it looks like I'm just going to say the horizontal asymptote. I put 2 S's in there. I put a bad word. Tote. All right. Breaks up. Remember, this is horizontal, so it breaks up our range. Our range. And the vertical asymptote that would be this line right here, breaks up our domain, right? Domain goes from here to here and then here to here. It breaks up, or we could say defines, breaks up our domain. All right. So let's write domain. Since we wrote range up there, our domain is also, right? So from negative infinity to 0, doesn't touch 0, union 0 on this side, almost touching that, to infinity. All right, we got a little bit more. We're going to hit the first page here and talk about just reflecting really quick and get this out of the way. So remember, there's an A and a B. Yeah, there are functions down here. So this right here means A equals negative 1. It's not in the function. It's not down there on that X. So that means I'm moving up and down like this, which is crossing the X-axis. And that's our B right there, right? It's down there in the function. B equals negative 1, which means I'm moving this way, right? And that means I'm crossing my y-axis. But look what happens to our points. And I'm just going to draw this point here. Those were our points that we pointed out were reference point, 1, 1. Well, let's see what happens to 1 when I reflect it across the x-axis. It comes here. And this negative 1, when I reflect it across the x-axis, comes up here. So what I'm going to see is everything has flipped over the x-axis here. But in actuality, if I flip it the other way, look, let's use the 1, 1 and negative 1, 1, and now we're going to flip over the y-axis from here to here instead of coming down here, but this guy goes over here. So it looks like whether we reflect over the x or the y, we're going to get the same exact graph. All right, that means this is an odd function. I'm going to stop this, and I'll talk to you soon on the next video.